All right, so today we are looking at 1.7 and 1.8, which is periodic trends, the favorites. So, so for periodic trends, people complaining about it memorize. Like people complain, like you memorize these trends, blah blah blah. It's not memorization if you understand why these trends work, which is why I cannot stress this enough. Is don't memorize these, know why it works, and you know why it works because of Coulomb's law, which I explained last video. Coulomb's law and shielding are kind of the two biggest things, but I always use Coulombic attraction and Coulomb's law to explain periodic trends when they're asking. Um, so basically, let's just go straight into it. Let's start with atomic radius, which is literally just how big the atom is. And um, if I'm given like a periodic table, I'll just like, actually, I'll do arrows. If it goes down and if it goes this way, is how big it goes. And the reason for this is um, the larger or the more you go down, the more shells there are. So naturally, the bigger the atom will be. And the reason why it goes bigger when you go to the left is because as you move to the right, there's more protons. And if there's more protons, the attraction between the nucleus and the outer electron becomes greater because there's a bigger charge in the protons, and that'll pull the electrons closer towards the nucleus, which will cause the entire atom to be smaller. That's why there's more protons, there's going to be a smaller radius. Next, electronegativity. And electronegativity just goes the opposite way, which is from this to this. Electronegativity is basically the atom's ability to attract electrons um, when bonded to another atom. It's just the atom's ability to attract other electrons from another atom. How do we think about this? Well, oh wait, why did I draw this way? Sorry. Well, if you as it goes up, right? What happens is the atom is smaller itself. So what happens is other electrons are able to be closer to the original nucleus's protons, and that'll cause the attraction to be greater. While moving to the right, as I said, there's more protons, and that'll cause a bigger attraction to other electrons from other atoms, right? Ionization energy next is just the energy required to remove outer electrons, and it's the same trend because they're mostly the same things. Um, as you move to the top, the valence electrons will be closer to the nucleus, so it'll be harder to pull out. And while you go this way, there'll be more protons, so the attraction between the valence electrons and the nucleus will be stronger, and it'll be harder to pull out. And another big thing you'll see is they love asking ionization why there's such big gaps in ionization energies when you're pulling out. Like, say for sodium, your first ionization energy is 498, your second one is 4560. The reason for that is because there's only one valence electron for the first one. So once you pull that one, you have to pull out core electrons, which is why it takes more energies. And you'll see that with this is for sodium, for magnesium, 736, 1445, and it'll jump to 7730 because you pull out the first one, pull out the second one, which are both valence electrons, and then when you pull out the third one, it's a core electron. So that is important to remember. Um, okay, electron affinity now is the energy released when an atom gains an electron. And basically, most of them, they lose energy. They release energy when an electron is gained. And although it both could be endothermic and exothermic, but most of the time it'll be negative. Um, So yeah, that's just something important to remember. And then valence electrons and ionic compounds. Well, valence electrons is just the electrons in the most outer shell. And then and then ionic compounds is basically when one metal and one non-metal, most of the time it's one positively charged atom and one negatively charged atom, when they're mixed together. So say for trying to think of something, like we can just say like H2O, we'll do water, H plus and O2 minus will create H2O. And that's caused when an oxygen will gain 2 electrons from, or gain 1 electron from each hydrogen atom, and that's how they bond. And that's for the valence electrons. So it'll kind of look like 1 oxygen, and then 2, and then these are H's. Cool. That's pretty much all you need to know for the last 2 lessons of Unit 1. I'll see you next unit.